Welcome back. So today we're starting our new section, our last section of chapter 4. We're going to be doing linear programming, which sounds intimidating, but is actually one of the most interesting pieces of this chapter. Because when we get to tomorrow, where you get to see the word problems involved in this, you'll get to see what actual businesses, what companies and corporations have to do to determine how much profit that they can make off of their products. So it's actually really applicable and really interesting. But today, first, we have to get through the background knowledge of everything, okay? So we're going to have a lot of vocab, a little bit of graphing, but then tomorrow we get to the real meat of it, why we're learning all the stuff that we're learning today. So the vocab I want you to know. First, linear programming is a method for finding a minimum or maximum value of some quantity given a set of constraints. The constraints form a system of inequalities and form the feasible region, which is all the values that satisfy the constraints. So like that double shaded area that we're talking about, or that we were talking about the last 2 days, that's the feasible region. Then the quantity we're trying to maximize is called the objective function. This is usually modeling cost or profit. Obviously, if we're talking about cost, we're trying to minimize cost or maximize our profit. That's what businesses are obviously after. So what the problems end up looking like is something like this. You'll have a set of inequalities that you have to graph and find the feasible region. And you'll have the objective function that you're trying to maximize or minimize. All right. Excuse me. So let's get graphing. So here we have x being greater than 2. So remember, that is a perfectly vertical line. And we want x to be greater than 2. So we're looking for all of the values here. Then we're looking for y to be greater than 3. Y gives me a perfectly horizontal line. Now, here's the part that's a little bit different than what we've done before, because we are going to end up graphing 4 inequalities, right? I don't want to have a quadruple shaded region. That's going to get so unbelievably messy. So what I'm going to do instead of creating this horrible, messy region, what I'm going to do is I'm going to erase whatever I don't want. So it's going to be very important that you have pencils for class for these last couple of days, because what I've been doing on the board and telling you, hey, don't do this yet, when I was erasing, that's actually what we're going to do now. So you can actually see the feasible region easier. So if I want greater than that line, it means I don't want anything that's less than it. So I'm going to erase anything I don't want. So that's kind of the strategy we're talking about here. Legitimately graph the first one, and then we're going to be erasing every time thereafter of anything that we don't want. Here's another horizontal line at 6. I want less than that line. So less than that line, I'm going to erase what I don't want. And what I don't want is what is above that line. So I say goodbye to everything above it. And then this one I'm going to have to alter. I'm going to have to subtract that x. So here, a y-intercept at 10, slope of 1, or -1, I apologize. So if I want everything less than that line, I'm going to erase everything that is above that line. And you can see the region that I have left. I have that little trapezoid. So Now I have that region. And again, I find this honestly the easiest way. Rather than shading 4 times, shade the first time and then just start hacking away at it. Take away from it. And now what I'm going to do is I'm going to take any vertice. And what I mean by vertice is edge. So there is a vertex to one of my edges. Okay? 2, 6. Here's another one. 2, 3. Here's another one right here. 7, 3. And then there's one right there. 4, 6. So after you get your shape, I want you to find all of those vertice points, okay? All of those kind of corners. And now this function right here, we are going to evaluate it using that, okay? So I'm going to rewrite that down here so when I scroll down I can still see it. But I'm going to evaluate C for every one of these. So 2 times x plus y. So 4 plus y is 10. 2 times x plus y. 4 plus 3 is 7. 2 times x plus y. 14 plus 3 gives me 17. 2 times x plus y. 8 plus 6 is 14. So I take that objective function, and for every one of those vertices, I evaluate it because the minimum and maximum values are going to occur at those vertices. Okay, now I'm not going to show you the mathematical evidence of that. I just need you to understand that's where they are going to occur. So you can see the minimum value occurs at the vertex 2, 3. The max occurs at the vertex 7, 3. So it is a somewhat lengthy process, but it is completely doable. All right, so we're going to go through 2 more examples of how to do this so you guys can get really good at it. All right, so my first line, x is greater than 0. X is a vertical line. Greater than 0 means I'm talking about this side of it. Y greater than 0, a horizontal line. And if I want everything greater than it, means I don't want what's less than it. So I'm going to erase this little part down here. So essentially all that's done is identified that we're looking for the first quadrant. That's really all that's happened here. All right, let's graph that one. Y-intercept up at 4. And then slope of -2. Down 1 over 2. Down 1 over 2. Down 1 over 2. And if I want less than, means I don't want anything greater than. So I'm going to come and I'm going to erase everything that is above that line. Okay, this is why it's going to be very important that you have a pencil for class. And finally, this one, so we start up at 10, and then -2, down 2 over 1. So I make my line, And if I want everything less than it, means I don't want what's greater than it. And now we can identify my vertices. So I have vertices at 0, 0, oh, at 0, 4, oh, changed color on me, 0, 4, at 4, 2, and at 5, 0. So I've identified all of my vertices, and now I look at my objective function, 3x minus y. So 3x minus y. So here, 3 times x minus y just leaves me 0. 3x minus y gives me negative 4. 3x minus y, 12 minus 2 gives me 10. 3x minus y leaves me 15. So after I find my vertices, I plug them in to my objective function so I can find my minimum or maximum, depending on which one I'm looking for. All right, last example, and then we'll be done with these notes. So again, let's go and graph all of these. X is greater than 1. X gives me a vertical line, and I want X being greater than 1. That's going to be all throughout here. Y being greater than 2. So I put in my horizontal line, and if I want it greater than 2, means I don't want anything less than that. Start up at 7, and then down 2 over 1, down 2 over 1, down 2. Oh, I'm sorry. That point should be right there. Down 2 over 1. And this one right here. Starting up at 1, then going up by 2's. All right. So if I want everything that's less than the red line, that means I'm going to erase everything that's up here. And if I want everything less than the red line, or less than the black line, that's going to be everything right here. All right. So this one. Oh, and I'm sorry. I'm not going to be using those. So when we go to find our vertices, I have one here, 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 and here. Okay, those are going to be my vertices. So my vertices are at 1, 2, 1, 3, 1.5, and up at 4, then 2.5, and up 2. All right, so that is my region that I'm going to be looking for. And again, I'm going to be using that equation to check all of my points. So 4x plus y is what I'm plugging all of my points into. So for 1, 2, the C value is going to be 4 times 1 plus 2. So my C is going to be 6. For 1, 3, I'm going to get a C of 7. For my 1.5, 4, I'm going to end up getting, well, 4 times 1.5 is 6, plus 4 is 10. 4 times 2.5, well, 4 times 2.5 is going to be 10, plus 2 is going to give me 12. So then I'm evaluating this. My max is going to be here at 2.5, 2. My min is going to be at 1, 2. All right, so lots and lots of good stuff in here. All right, so I want you to summarize that process for me. Okay, write out what process so you can recall the steps you need to take to solve these problems. So write me that summary, come back to class, ready to do your practice work.